Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Abdul Awal Hussein, and today I'm doing the presentation of our assignment, our group assignment. My part is the genetic algorithm. So, as we know, electricity is a necessary part of modern life, and transmission of electricity from generation source to end users is a critical component of the overall electrical power system. So this part is talking about the introduction of our project, but I will be more specific. So I will present the more important points like this one. The use of optimization algorithm is one method for optimizing the design of electrical power distribution systems. Also, optimization algorithms have been widely used to solve a complex optimization problems that cannot be solved analytically in a variety of fields, including electrical engineering. So our title is this one, genetic algorithm. Genetic algorithms are type of optimization algorithm that is based on natural selection and genetic principles. They involve the selection, crossover, mutation operators being used to evolve a population of solutions. So genetic algorithm has been shown to be effective or best way for solving complex nonlinear optimization problems with a large number of design variables, and they have been applied to a lot of problems in the electrical power sector, including distribution network optimization, distributed generation system design, and energy management system optimization. So in this report, we look at how genetic algorithm can be used to be optimize the design of an electrical power distribution system. The goal of this optimization is to find the optimal distribution system configuration that minimize or reduce the cost of serving electrical demand while meeting a certain constraints, example power flow limits, voltage limits, and other problems for electrical. So the steps involved in setting up the optimization problem, including the definition of the design variables and the fitness function, will be explained, and the result of the optimization process will be discussed. So this is the problem statement. The design of an electrical power distribution system entails determining the type and size of power distribution equipment, as well as the configuration of transmission lines, in order to meet the electricity demand in cost-effective and reliable manner. The problem can be expressed as an optimization problem with the goal of determining the set of design variables that minimize given objective function under certain constraints. So objective of this project is, the primary goal of this research is to show how to use a genetic algorithm to optimize the design of an electrical power distribution system. So the problem we found is a problem for electrical power distribution system. So our objective is this, to create an optimization model based on the genetic algorithm for the design of an electrical power distribution system. And the second is analyze the performance, the genetic algorithm's performance. So this is the literature review of our design. There is a lot of reference we mentioned in the reference part. So this is the methodology part. We are using MATLAB to solve these problems. We implemented the genetic algorithm-based optimization model for design on an electrical power distribution system. The model is made up of a fitness function that takes as input the design variables such as type and size of the power distribution equipment and transmission line configuration. In return, A fitness value based on the optimization criteria, example, cost, reliability, energy efficiency, using a variety of genetic operators. The genetic algorithm seeks the set of the design variables that minimize the fitness of function, example, crossover and the mutation. So this is the upper code. So this is the number of design variables, three. So in lower bounds of the design variables we have 0, 0, 0, and upper bounds for the design we have 1, 1, and 1. So next we will define the fitness function, and next we will do the we will run the genetic algorithm by taking the maximum generation heart rate, population size fifth. So then we will get we will simulate the optimal solution as we will see in the result part. So our function is y is equal to fitness of x, while y is equal to x, so 1 plus x2. It is very simple. So this code divides an optimization problem in 3 design variables as I stated before, and assigns lower and upper bounds to them. The fitness function one is then divided with we take a set of design variables as input. So in this code, this is the result we got. The optimal solution is we have 2.8, 7.8, 0.5, also 7.5, and 9.8. The fitness value we get here is 0.000200248. So the genetic function, a built-in function for the genetic algorithm in MATLAB is used to solve this optimization problem. The fitness function, the number of design variables, and the lower and upper bounds of the design variables are all inputs to the GA genetic algorithm function. It's also accepted various control options for the optimization problem, such as the maximum number of generation and population size. So this is the GA function. Then iterative reliability, a population of solutions referred to as chromosomes using selection, crossover, and mutation operators, returning the set of design variables that minimizes the fitness function. The optimal solution is found to P 2.8, 7.5, 9.8, and the width, and the fitness value of this one is 0.0002020248. So the result of our study shows that the genetic algorithm is effective optimization method for the design of analytical power distribution system in all of test cases. السلام عليكم ورحمة الله وبركاته.
And hello, my name is Nimko, and I'm a group 2. I will present my particle swarm optimization part. In introduction, we see the distributed generation is a key technology for improving the sustainability, reliability, and efficiency of electrical power system. By using small-scale decentralized energy generation unit that are connected to the grid at the distributed level. Also, distributed generation unit can help to reduce the reliance on fossil fuels to improve system reliability and decrease transmission loss. The integration of distributed generation units into electrical grid can also present challenges such as power flow issue and voltage stability problem. Particle swarm optimization is a population-based optimization algorithm that has been widely applied to verify for a variety of problems in electrical engineering, including optimization of distributed generation, placement, and sizing. The objective of this is that the placement and sizing of distributed generation units in an electrical power distribution system can be formulated as an optimization problem, where the goal is to find the set of design variables such as location and capacity of the DG unit. Minimizes the cost of saving the electrical demand while meeting certain constraints. An example of like power flow limits, voltage limits, and other operational or technical requirements. Um, to implement the optimization of DG placement as sizing in MATLAB, you can use the particle swarm function. The particle swarm function takes as an input the fitness function, the number of design variables, and the lower upper bounds for the design variables. So to set up the optimization problem, we first define the design variable and their bounds. Next step, we define the fitness function, which takes the design variable as an input, returns a fitness value based on the optimization criteria. Once the fitness function and design variable have been defined, we can use the particle swarm function to search for the optimal solution. This code defines a problem with 20 design variable and sets that lower and upper bounds, and it then defines a fitness function that takes a set design variable and the number of design variable as a input and returns of a fitness value. And fitness value calculates the sum of all the design variable and returns it in the fitness value. And the particle swarm function is used to search for the set of design variable that minimize the fitness function. And the option is input is used to specify the maximum number of iteration and the swarm size for particle swarm optimization. Finally, the optimal solution X and fitness value are displayed. And conclusion, and the output of optimization and the relative changes in the objective value of the last option's max iteration is less than the option's function tolerance, which indicates the optimization algorithm has determined because the relative change in the objective value of the specified number of iteration options max has fallen below a certain threshold of options function tolerance. And this can occur when the algorithm has coverage and as a solution or when it is unable to make further progress. And that's my part. Thank you so much.
السلام عليكم ورحمة الله وبركاته. My name is Saleh Abdul Qasim Saleh. My matrix is GE 22001. I want to presentation my group. I want to talk about fuzzy logic design. To design fuzzy inverse system, you need to identifying the input and output value. Use the fuzzy logic design in the MATLAB. The fuzzy logic design has many apartments, but one that use the best prediction. Trapezium value and trapezium fuzzy in numbers. They are many input and output. For example, each month for 2009 and 2001, he has 3 input and 3 output. He showed before the table this. The input use these processes in the trapezium fuzzy number of a single row. The output is midpoint For each single import, the shower the table next it. This next table is a tick table output. Put trapezoid fuzzy number. This the second the fuzzy system 1 until the fuzzy system 13 equal these variables. The second step is a give arrows to input and output of the month, which are the figure this input and output. Input is have 1 until 13. You put values here, and you can see here, and you can see output here. The last year is beginning for December. Yes, here is sorry. The last years begin for December. In December in 90,000 in 2019 and to August 2021 they are is no actor value and as import the so give prediction of the years. I use a month to give me actor value as import. That month is a look for the month is to look for average value of months. You like this value of all January. It is will give me and if you going give me a prediction of the next year January and the so on. This before. Thank you. This
Bismillahirrahmanirrahim. My name is Ahmed Jamal Osman, and today I would like to present our mini project of advanced functional mathematics. I am a for group 2, and here is my teammates. First one is Saleh Abdul Qasim, Saleh Abu Atiyah, Abdul Qani Abu Hussein, and Nimko Jama Muhammad. The introduction of artificial neural. Artificial neural is a type of machine learning model that is inspired by the structure and the function of human brain. Artificial neural can consist of layers interconnected neurons which process and transmit the information. They train using large set of library data and can be used for wide variety of tasks such as image, speed, and recognition language translations, making artificial neural the backbone of deep learning, which has led many recent breakthroughs in artificial intelligence. So here we are looking for the types of layers of artificial neural network. The first layer is called input layer, hidden layer, and output layer. The hidden layer is the first layer of artificial neural that receives the input information. The hidden layer, there can be a single hidden layer or many hidden layers, multiple hidden layers. This hidden layer is perform the various types of mathematical computations of the input data. The output layer is we obtain the result that we through the rigorous computation performance. And here is our layers. Some are hidden here. 3 layers: the input layer, the output layer, and the hidden layers. The input layer is if you think you hide here, and then you go to the hidden layer and then the output layer. The methodology. Various fundamentals of this process is to utilize artificial neural network in MATLAB software. We are going to implement the MATLAB software using the data from the University of on UTHM characteristic assumption from 2009 to 2021. First here is we are going to use the 13 columns for xt and 1 column for yt, and then we are going to input. The output will be provided into the heading, and the input and the output will be provided to the heading layer. First, we have to do the iterations. The iteration after that is going to get the performance of this artificial neural network, training state, error histogram, aggregation, time series, and the error aggregation and the input error. So at the time we are going to find different value, we can do it back again using the performance or clicking the performance. Here we are trying to get it equal to 0.94994. The validation equal to 0.627, and our test will be equal to 0.52, and all are equal to 0.86. And this our performance. Our performance we have getting 1505 or 2.2638 at the approach 2. So we have here 3 lines. The first line, the blue line, which is train, and then the validation, which is the green line, and then the test. So in all we get it in here. Here is our target. The autocorrelation of errors. The autocorrelation, the highest reach is 7, and here the maximum and the minimum we reach it. And this are the instances. We have here the validation tests and the 0 errors. Also going to find the response of output elements of the time series. And here this graph is our output and the target that we're going to find. And finally we have get our forecasting. This is the actual forecasting. We from 2009 to 2021. And here the actual and the forecasted errors. The forecasted one is the blue line is equal to the forecasting, the actual, and the red one is the forecasted line is. So and the highest target is 3,500 and the lowest is 500. And in conclusion, artificial network or forecast is a prediction of future or the past event using historical data. The slow forecasting is common application using techniques such as artificial neural network in MATLAB to estimate the consumption price and load demand and assess the performance. In this paper, we have used from the data from 2009 to 2021 to train the neural network to forecast the increased slow consumption of infrastructure and Malaysia. The network is trained multiple times to improve the accuracy and reliability of forecasting. So that's all our presentation. Assalamu alaikum.